Today, I'm really excited to be giving you a sneak peek at the beta version of Code, or the Cislunar Orbit Designer. This tool is designed to make the cislunar orbit regime a lot more accessible to the average STK engineer. At its core, it's a database of potential cislunar orbits that you can easily query and add to STK. Right here, you can see a series of orbits in the butterfly northern orbit family. If we hit run, we can see all of these different orbits going about their orbital period. The orbits are even separated by color gradients, so you can tell the orbits apart. I'll start with the basics. The orbit database that is used by Code can be queried in terms of orbit families. For example, we can start by looking at the Halo L1 Southern orbit family. At the bottom, you can see that there are 3,378 orbits in this family. On the Plot tab, you can select Family Parameters, and you can compare the stability index, period, and Jacobi constant of all of the different orbits. Let's say we wanted to look at them relative to the orbit ID. If we plot, we can see from orbit ID to 0 to 3,300 or so, these are the different stability indices and periods of the orbits. We can also look at these orbit families' eigenvalues, both mode 1 and mode 2, very easily from the screen. Since there are 3,378 orbits in this orbit family, we're going to have to narrow down our search. So let's say I want to look at orbits that are between a Jacobi constant of 2 and 4. If we apply this filter, we still haven't separated out any orbits. So let's say between 2 and 3. 700 orbits remain. Next, we can use the data thinning tool to select 1 out of every 70 of the 713 orbits. We hit thin data. Now we only have 10 orbits left to look at. We can select export to master table to add them to this table. Also clear table before running to remove all of these butterfly northern orbits. Now you can see it is populating a set of 10 different orbits in this family. Let's say we wanted to add specific orbits from our master table to our STK scenario. To do this, we go to the STK integration tab, which has the different options for propagating orbits in STK. We can select by clicking individual orbits, control clicking specific orbits we want to add, or shift clicking to select a range of orbits. If we propagate single mode, then we're adding a single satellite for each of these orbits for a defined number of orbital periods. Let's say we want each of them to make 2 full orbital revolutions. We hit propagate, and all 10 of these orbits are added to STK. If we hit run, we can see that each of these will make 2 full revolutions before ceasing to exist. Alternatively, we can add constellations. Let's say we wanted to evaluate a lunar positioning system constellation. So we wanted to look at this specific orbit, and we wanted to add 5 evenly distributed satellites in this orbit. We select constellation, select the number of satellites we want to add in that constellation, and propagate constellation mode. Let's say we wanted to compare a Halo L1 northern satellite constellation to, an axial L1 satellite constellation. We only want Jacobi constants from the same range, so we apply the filter. There are 943 orbits remaining. We thin the data, and we add these to our master table. We can take a look at the different orbits in this table, take a look at some of their family parameters, and decide which one we want to add. And we select this one right here. Go to STK integration, and we can add another constellation of satellites evenly distributed about this funky orbit, and we can compare the 2 orbits. And also, there are some preset graph types. So if you go to the report and graph manager for a specific object, you will see that there are some predefined graphs that you can easily generate, or reports that you can easily generate to assess the different satellites that you have added to your scenario.